Picture this. Warm, gooey cookies fresh from the oven, crunchy caramel candies, velvety chocolate cakes and waffle cones stacked high with scoops of ice cream. Is your mouth watering? Are you craving dessert? Why does sugar have such a powerful hold on us? What happens in the brain that makes sweet treats so hard to resist? Sugar is a type of carbohydrate found in almost everything we eat. If you check food labels, you'll spot glucose, fructose, sucrose, maltose, lactose, dextrose, and starch, all different forms of sugar. Even natural sources like honey, fruit juice, and high fructose corn syrup fall into the same category. But sugar isn't just in candy and soda. It hides in unexpected places: tomato sauce, flavored yogurts, granola bars, dried fruits, and even so-called healthy drinks. Since sugar is everywhere, understanding how it affects your brain is crucial. What happens when sugar touches your tongue, and does eating a little lead to craving more? The moment you take a bite of something sweet, say a spoonful of cereal, sugar molecules activate taste receptors on your tongue. These receptors send signals to your brain stem, which relays the message to different parts of your forebrain, including the cerebral cortex. This part of your brain processes different tastes: bitter, salty, savory, and in this case, sweet. But the real action happens when the reward system kicks in. This system, a complex network of electrical and chemical pathways, helps answer one key question: should I do that again? That warm, fuzzy feeling when you eat a cookie. That's your reward system lighting up, telling you, oh yes, that was good. And it's not just food that triggers this response. Social interactions and addictive substances like nicotine and alcohol all activate the same pathways. But there's a downside. Overstimulation of the reward system can lead to cravings, loss of control, and increased tolerance, meaning you need more sugar to feel the same pleasure. Once you swallow that sugary bite, the process doesn't stop at taste. Sugar travels to your stomach and gut, where sugar receptors, different from taste buds, send messages to your brain. These signals help regulate appetite and insulin production in response to the sugar spike. At the core of the reward system is dopamine, a neurotransmitter responsible for pleasure and motivation. Dopamine receptors are found throughout the brain, but they're concentrated in areas that reinforce pleasurable behaviors. Addictive drugs like heroin, nicotine, and alcohol flood the brain with dopamine, creating an intense high. Sugar isn't as extreme, but it also spikes dopamine levels, making it one of the few foods that directly impact the brain's pleasure pathways. Compare that to broccoli, which does nothing to your dopamine levels. No wonder kids aren't begging for more vegetables. When you eat a nutritious meal, your dopamine levels rise, but over time, if you eat that meal repeatedly, your dopamine response decreases. This is an evolutionary trait. Our brains encourage variety, ensuring we get a diverse range of nutrients. But sugar behaves differently. Instead of leveling out, its dopamine response remains strong, reinforcing repeated consumption. The more sugar you eat, the more you crave it, much like addictive substances. Sugar has both short-term and long-term effects on brain function. All right, let's dive into the short-term effects of sugar on our brains. First up, we have the dopamine spike. When you consume sugar, it triggers the release of dopamine, activating the brain's reward system and reinforcing the desire to consume more. Next, there's the energy boost and crash. Sugar gives you a quick burst of energy by spiking your blood glucose levels, but unfortunately, this is often followed by a crash, which can lead to feelings of fatigue, irritability, and difficulty concentrating. And finally, increased cravings. The brain starts associating sugar with pleasure, which can lead to a cycle of overconsumption. This means the more sugar you eat, the more you crave it. Long-term effects of high sugar intake are quite concerning. Firstly, cognitive decline. High sugar intake has been linked to memory problems, reduced learning ability, and a higher risk of Alzheimer's disease. Additionally, increased inflammation. Excess sugar causes inflammation in the brain, affecting mood, cognition, and long-term brain health. Mental health issues are also a significant concern. Studies suggest a link between high sugar intake and mood disorders like anxiety and depression, likely due to blood sugar fluctuations and inflammation. Lastly, reduced brain plasticity. Too much sugar weakens the brain's ability to form new connections, which is crucial for learning and adapting. Think about all the forms of sugar we've mentioned. While chemically distinct, they all trigger the same response in the brain, a pleasurable dopamine spike that encourages repeated consumption. In moderation, sugar isn't harmful, but too much sugar can hijack your brain's reward system, making it harder to resist cravings. So, is sugar addictive? In many ways, yes. Eating too much sugar rewires the brain, leading to a cycle of dependence. But the good news, you have control. By being mindful of your sugar intake and making small, gradual changes, you can rewire your brain's cravings and create healthier habits. Enjoy your dessert, but don't let sugar control you.